This video covers geometric sequences, so we're going to cover some terminology first. So a geometric sequence is a list of numbers where the ratio of successive terms is a constant. This constant is also known as the common ratio, the constant multiplier of successive terms in a geometric sequence. In a geometric sequence, each term is formed by multiplying the previous term by a constant. And like I said, the constant is called the common ratio, and its symbol is r. We can find r by having the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term. There is a pattern there, and you can continue on. The general term of a geometric sequence is given by the formula you can see there, where a is your starting term, r is the common ratio, and n is the term number. We are now going to answer some questions. So is each sequence a geometric sequence? If so, find the common ratio. To prove this, we need to find two common ratios and then compare them to see if they are. So we'll start with R1. And R1 is going to be our term 2 divided by term 1. In this case, it's 3 divided by -4, and we can leave it as that. We're going to find our common ratio 2 now, and we're going to use term 3 divided by term 2. So in this case, it's going to be -2 1/4 divided by 3, which equals -3/4. Since both r's are the same, we can conclude that the sequence is geometric. We're going to follow the same steps for this question here. Since the r values are different, this is not a geometric sequence. Find the pronumeral in each geometric sequence. We know that r is common. We know that r here can be found by going t2 divided by t1, or t3 divided by t2. R is the same. Because R is the same, we can use this to find an unknown, which is what we're going to do. So we have our t1, t2, t3. I can now substitute these in to solve our letter, our pronumeral. It becomes a regular equation, and we multiply our 12 up, and y is going to equal -48. We'll do the same here. We then can square root to get plus or minus 10. Find the formula for the nth term of each sequence. This time we will be using the formula. And we'll start by writing down what we know. We know A is 2. We know R will be 10 over 2, which is 5. And N we don't know. So we can substitute these in. So Tn will be 2 times 5n minus 1. And that's it. What is the ninth term of each sequence? So again, we will be using the formula. Write down what we know. And then substitute in to find our answer. Which term of 6, 36, 216 is equal to 7,776? I'm going to start this one by writing down what we do know. We know A is 6. We know R is 36 over 6, which is 6. And we know Tn equals 7,706. I'll write down our formula. And all we're missing there is our n value. So let's substitute our values in. Just to note, 6 times 6n minus 1 is 6 to the power of n. So we will do that change now. So 7,776 equals 6 to the power of n. We are going to use log base 10 to find our answer. So log to both sides. Now remember, our log laws say that if we have a power on the outside, so our n, that can be brought out the front to be a coefficient. So log 10 equals n log 10, 6, which we can then divide both sides to make n the subject and put it into a calculator to get 5. So n, this will be our fifth term. So the first term of a geometric sequence is 7, and the sixth term is 1701. Find the common ratio. Let's start by writing down what we know. And we know T6. Alright, remember our formula. We're going to be using our sixth term, so we know n can also equal 6 for this example. So we're going to say 1701 will equal 7 times r and 6 minus 1. We can divide by the 7. 243 equals r to the power of 5, because 6 take away 1 is 5. We can then root both sides and we get r equals 3. Alright, so we're going to do a recap, and we know that a geometric sequence, each term is formed by multiplying the previous term by a constant, and that constant is known as the common ratio. On the screen you can see how to find the common ratio, and below that you can see the general term of a geometric sequence.